Hi, welcome back. Now, we've been tracing the evolution of voting technologies through the latter half of the 1800s, and it's important to step back a little bit and think about what else is going on in technology during this historical period. In the US, in the late half of the 19th century, the Industrial Revolution was in full swing. And the Industrial Revolution brought many amazing technological advances, in particular, just fantastic progress in our ability to design and construct mechanical devices. These devices were the product of a wide range of inventors, and some of those inventors looked around at their society and they saw the problems with voting on paper ballots. They saw the massive political corruption, especially in the big cities. And they decided to apply themselves to trying to come up with a better voting technology. And quite naturally, they turned to the cutting edge technology at the time. And what they came up with was devices like these. Mechanical voting booths. This kind of technology, which came into existence towards the end of the 1800s and was rising to prominence for many years, became in the first half of the 20th century the most widely used voting technology in the US. The voting machine, as you can see here, represents a major shift from paper ballots. Like voice voting, these machines make a direct record of the voters' choices, in this case through a system of levers and gears rather than through having people write down the choice. But that kind of mechanical impartiality was seen as a security feature. These machines continued to be in use in the 20th century, and in fact, my own first voting experience was on a device not that dissimilar to this one. Just a massive refrigerator-size voting machine. And you can see here one manifestation of the complexity of US-style ballots. While some countries only have one or two questions, our ballots can have dozens and dozens of candidates for each. And that necessitated a very large, very expensive, and above all, very complicated machine. These could have thousands of moving parts. But the security claims people made about these machines were very strong. Early inventors claimed that they were going to provide absolute secrecy, since it was just a machine you were telling your choice to and you had no ballot paper anyone else could see. They also claimed that the machines would be absolutely tamper-proof. These impartial, high-tech machines were supposedly going to be saviors for democracy. Let me illustrate the voting process using a slightly more recent example of such a machine. This is more similar to the one I first voted on. So the voter makes his or her selections using a series of small levers inside the voting booth that you can see through the curtain here. Notice again how big the machine is. Then inside the booth, the levers are laid out something like this. There's a small lever for each candidate, and then a larger lever that will flip all of the smaller levers for a party's ticket. Supporting hall ticket voting. On the right, you can see a little bit of the mechanical design of one of these machines coming from a patent application from the late 1800s. You can see that inside the machine, there's a really complicated arrangement of gears and wheels. A lot of the complexity comes from integrating the various different rules for balloting into a physical manifestation, into a mechanism. So the mechanism would try to prevent you from voting for multiple candidates if you're not allowed to vote for more than one, and so forth. Then inside the machine, under lock and key, would be a counter mechanism that would total up the number of voters who had flipped a lever for each of the candidates on the front. So this is another feature that was one of the really neat innovations in lever-style voting machines. There would be a big lever at the bottom that when you went in the voting booth, you'd pull the big lever first to close the curtain behind you. Then you'd vote on the little levers, and then you'd pull the big lever again to open the curtain. At that point, the machine would tabulate the vote, reset all the levers to the unvoted position, and you could leave the voting booth. But this was a neat idea because this was something that the voting officials watching you could see and know that you had done the process appropriately, including the final step necessary to cast your ballot. So here's an illustration on the back of the machine of the gear wheels that would increment, these mechanical counters associated with each choice on the ballot. And these were actually what was the only record of the vote cast in the machine. So we suddenly have no true physical record of each vote. Instead, we just have a tally, and the tally is maintained in the mechanical state of these wheels. This was the design of lever-style voting machines. The election officials had an easy job at the end. They just had to open the back, read off the numbers from all of these wheels, and report them. This could be done right at the polling place at the end of the day. It made for very rapid returns and potentially got rid of a lot of the subjectivity, a lot of the room for fraud in the counting process, as well as eliminating the threat of chain voting that we saw with the Australian secret ballot. But there was still a lot that could go wrong. It's time to pause and let you try to puzzle out what some of the problems with lever-style voting machines might be. See you back in a minute. So there was plenty that could go wrong with lever voting machines, and a lot of it did. For the first time, there was no physical record, there was no way for the voter to verify with their senses, rather, that their intended choice had actually been recorded as their ballot. So you think about it with voice voting, you could go and look that your name was right on the list. With a piece of ballot paper, you actually had a record you could see with your eyes. Here, the only record of your vote was on those wheels in the back in a place that voters couldn't see during the polling process. So as a complicated machine with thousands of moving parts, failure was inevitable. And failure often occurred, especially with all of these gears and wheels. There were many recorded cases of times when a machine was found to have a small broken part somewhere in one of these mechanical counters. You can see there in the center of the photograph the small plastic tabs, the gear teeth on one of the counting wheels. If one of those tabs broke off, then the counter could stop incrementing. And it might stop incrementing after anywhere in the middle of the counting process. Since there was no record of each vote, there was no way to tell if you opened the machine at the end of the election and found that one of the parts was broken. It could have broken before the election started, it could have broken in the middle, it could have broken right before the last vote. So any of those missing votes that disappeared because of the mechanical failure were unrecoverable. Now the problem was worse than that, though, so that you had the possibility of just naturally occurring mechanical error. But there was also the possibility of sabotage. So a dishonest technician could actually make the machine fail in just the same way by breaking off one of these gear teeth, by making the counter not increment properly. And it would be almost impossible to distinguish between deliberate sabotage of the counter for the criminal's least favorite candidate and a natural failure, just bad luck. This kind of problem was widely suspected to happen on a wide scale with mechanical lever machine designs. Another story that is at least in the folklore of election officials about these machines was that a common way of committing fraud with them was to take a little piece of pencil lead. Again, the lead pencil is a favorite tool of election fraudsters. To take a little piece of pencil lead and jam it into the gears of the candidate you oppose. A technician could do this before the start of the election, and then it would prevent the wheels from advancing properly, but also just gradually wear down the pencil lead over time. At the end of the count, when they'd open the machine, there'd be some missing votes for that candidate, but all the evidence that would be left would be a little pile of graphite dust somewhere in the mechanism. Very, very sneaky. Initially, politicians in corrupt jurisdictions were afraid of these machines. They saw the lever machine as something that would make cheating that much more difficult for them. But as time went on and fraudsters sort of became more accustomed to these machines and learned how cheating was possible, the fear of corrupt politicians gradually wore off. Governor Earl Long of Louisiana, the brother of Huey Long, another famous potentially corrupt politician, is reported to have said of these machines, "The voting machines won't hold me up. If I have the right commissioners, I can make dem machines play home sweet home."